Hello friends. So last class I discussed about the number system procedures, right? So one of the number system procedure I discussed, that is decimal to other number systems. Decimal, how we can convert decimal number to binary number, then octal number, then hexadecimal numbers, and the introduction of the number system also we have discussed. So today I will tell about the other number system to decimal number system. How we can convert binary to decimal, hexadecimal to decimal, octal to decimal, right? So before going to this thing, I want to tell one thing. Suppose this is a one kind of the decimal number, right? So when we start with a numerical, so how we have represented that 437 any kind of the decimal number, right? So here, so this is the unit place. This is the first unit place, first place. The second place, this is the third place. In this way, I can represent, right? This is the zeroth place, first place, second place, third place, right? So this number is equivalent to. So for case of the decimal number, base is the 10. How can you representing this decimal number in a other way, right? So this is the zeroth place, one place, second place, and third place. The base is the 10, right? So here I can write as a 0 to 10 to the power 0 into 0. See, base to the power that unit place into that coefficient. Okay, base to the power unit place and to coefficient plus here again base to the power unit place position into coefficient, again 10 to the power 2, 10 to the power base to the power the position into coefficient, right? Again 10 to the power 4 into sorry 10 to the power 3 into 4. Okay, in this way I can write 4370. This is the decimal to decimal conversion. Okay, decimal to decimal representation. So base to the power position into coefficient, base to the power position into coefficient plus base to the power position into coefficient. So if you calculate these things, same number you will get. Okay, now coming to that point, how can you convert the binary number to decimal number? So this is the decimal to decimal conversion or decimal to decimal representation, right? So I am writing one binary number, suppose 1100.1011. This is a one binary number, right? So first I am giving the, in case of the binary number, the base is 2, right? So first I am giving the position of that binary number. So this is the real number, this is the fraction number. For case of the real number, this is the position 0, 1, 2, 3, 4, 5, 6, 7. This is the minus 1, minus 2, minus 3, minus 1. After point, all the position will be like that. Minus 1, minus 2, minus 3, minus 4. Here it is 0, 1, 2, 3, 4, 5, 6, 7, like this way. Now, if you compare this to this, how this decimal to decimal conversion is taking place, okay? In this way, I have to do, right? First, I'm writing here. So, base to the power position into coefficient, right? So, 2 to the power 7 into 1. Base to the power coefficient, position into coefficient. Then 2 to the power 6 into 1. 2 to the power 6 into 1 plus 2 to the power 5 into 0 plus 2 to the power 4 into 0 plus 2 to the power 3 into 1 plus 2 to the power 0 into, sorry, 2 to the power 2 into 0, this 2 to the power 2 into 0 plus 2 to the power 1 into 1 plus 2 to the power 0 into 0 plus, now here base to the power position 2 to the power minus 1 into 1 plus 2 to the power minus 2 into 0 plus 2 to the power minus 3 into 1 plus 2 to the power minus 4 into 1. So it is very simple. The number, the base, then what is the number? I have to check the base. So first we have to give the position of those numbers, right? So here I have given the positions. Now base to the power position into coefficient. Base to the power position into coefficient. In this way I have to add. So if you calculate this thing, you will get 202.6875 approximate number. right? So this is the binary to decimal conversion, right? Binary to decimal conversion. In this way, in the same procedure, I can convert octal number to the decimal number. Okay, octal number to the decimal number. So the number system, the number system that is given, right? So I have to check the base of that number system, and after that I have to position those numbers, right? So base to the power position into coefficient. In this way I have to convert, right? Secondly, suppose octal to decimal, 7.12772. Okay. So for this case, this is the position 0. This is -1, -2, -3, -4, -5. The number is the octal number. This number I have to convert it into the decimal number, right? So again, base to the power, base to the power position into coefficient. Base to the power position into coefficient. Base to the power position into coefficient. In this way, I have to do. Right. So here I will get 10.16 decimal number. Base to the power position into coefficient, base to the power position into coefficient plus base to the power position into coefficient, in this way. For case of the hexadecimal number. So hexa to decimal. The number is given 1F.01B. This is the hexadecimal number, right? So 1, so this is 0, this is 1, right? This is -1, -2, -3. After point, -1, -2, -3. Again, I am writing this 1 is 1, but for F, I cannot multiply F with any number, right? So F is equivalent to 5. If you remember this thing, after 9, 10, 11, 12, 13, 14, 15, right? So A, B, C, D, E, F. In case of the hexadecimal number, this 10, 11, 12, 13, 14, 15, this can be represented as A, B, C, D, E, F. So A, F is equivalent to 15, B is equivalent to 11. Okay. So now the conversion. Base to the power position. Base to the power position into coefficient 1 plus base to the power position into coefficient. Coefficient is F. F means 50 plus base to the power position into coefficient plus base to the power position into coefficient plus base to the power position into coefficient B. B means 11. Okay. So here you will get 31.0065. Okay. This is the hexadecimal to decimal. So whatever hexadecimal number, if any number is there, number is greater than 9, so that is A, B, C, D. So after positioning those number, you have to convert F as a 15, B as a 11. Then base to the power coefficient, base to the power position into coefficient, base to the power position into coefficient. In this way, I have to do, right? So this is the procedure. Other number system to decimal number. So last class I discussed decimal to other number system. Now other number system to decimal. Okay. Now some other number system, right? Other number system to other number. There is no concept of decimal number now. Okay. Other number system means binary, octal, hexadecimal. These are the other number system apart from decimal number system, right? So how can you convert binary to hexadecimal and vice versa, or vice versa, right? Binary to hexadecimal or hexadecimal to binary. So there is a one piece, that is the 8421 format. Okay. So I am writing number first. Suppose 1101, 1 1 1 1, okay, 0 1. Okay, this number is there, right? Now, so in case of the hexadecimal, this is a binary number, right? Binary number. In case of the hexadecimal number, so I told that each hexadecimal number contains 4 digits, right? So I am combining 4 digits like this way. So in case of the real number, in this way I am combining. This 4 digit is 1 and this 4 digit is 1 number, right? After point, decimal point, I can combine like this way. Okay, so suppose any number is there like this number, okay, and this number is there, how can you combine, so this 4 digit one number and this here is 3 digit, but in front of this number you can put 0, so this 4 digit one number. Here also in this you can see 3 digits are there, you can put 1 0, so 4 digits one number, right? So if you want to combine each digits, so for real number you have to go like this way, for integer number, for fraction number you have to go like this way, right? Now above this number you can write like this way, this 8 foot 1, right? 1 2 4 8, right? So this 4 digit can represent as a 8 foot 1 format. This is 8 4, so above this one I have written 8, above this one I have written 4 2 1 like this way. Here also I have written 1 4 2 1 like this way. Okay, now see, so under 8 4 and 1 I have 1 numbers, and under 2 I don't have 1, right? Under 2 I have 0 only. Okay, here also you can see under 8 4 2 1 I have ones, right? So what do you have to do? Just you have to add only ones. Okay, the weightage of ones, these are called the weightage. You have to add weightage of ones, not add this one. Okay, so the weightage of this one is 8 plus weightage of this one is 4 plus weightage of this one is 1. These are called as a weightage. So above the number I have to write the weightage, right? So 1 2 4 8 like this way. 1 2 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3 like this way. So I have to add weightage of only ones, not 0. So here it is 13, right? Here I have to add weightage of all the ones. 8 plus 4 plus 2 plus 1. Here it is, I think 12, 3 and 15. Okay. Now again here I am writing 8 4 2 1. So I have to add only the weightage. So this I cannot add because here it is 0. So 4 2 1. I have to add only the weightage of ones. First you have to write like this way, 8 4 2 1. 8 4 2 1, 8 4 2 1 like this way. So here it is 4 plus 2 plus 1 is 7, right? So number is 13. In case of the hexadecimal, 13 is E, F, right? 10, 11, 12, 13, 14, 15, right? 13 is D. D, F, 15 is F. Okay? 0.7. This is the hexadecimal number, right? So what is the procedure? Again I am writing any binary number is there. First you have to combine 4 digit as a one number. Okay. In case of the real number like this you have to combine. In case of the fraction number in this way you have to combine. Okay. So after that above each and every number you have to write 8421. For this 4 digit I have to write 8421 and next 4 digit again I have to write 8421. In this way 8421, right? So I have to add weightage of only ones, not 0. Okay. So here it is 8 plus 4 plus 1, 30. Okay, 8 plus 4 plus 2 plus, here you have to add all the weightage because all the numbers are 1. Here it is weightage of ones only, 4 plus 2 plus 1. In this way you have to convert binary to hexadecimal. This is the easy procedure. Otherwise, you have to convert this binary number to decimal number, again decimal to hexadecimal. This is the long procedure. So in this way, I can directly convert binary to hexadecimal number. If you don't know this procedure, first you have to convert binary to decimal number, then decimal to hexadecimal number. This is the second procedure. Next is the suppose for binary to octal. Okay. And for case of the hexadecimal, vice versa, suppose any number is there, 240A.3C. This is the hexadecimal. How can you convert hexadecimal to binary number, right? So again you have to write. So this is a hexadecimal number, right? So each hexadecimal number contains 4 digits, right? So how can you represent 2 as a 8421 format? So first I am writing 8421. Okay. So here 4 digits are there. So 4 times I have to write 8421. And after the point again 2 times I have to write 8421 because each number contains 4 digits, right? 8421, 8421 I am writing here. Okay. So now 2. So for case of the binary to hexadecimal, what I told, I have to add weightage of ones, right? So for this the opposite thing is there. So 2, how from 8421 format, how we will get 2? So if we put only 1 here, so from this 2 I will get 2, right? So I have below this 2 I have to put 1 and other place I have to put 0. Okay, from 8421 format, how I will get 2, right? So only if we consider only 2, here I will get 2, right? So below this 2 I have to write 1 and for other place I have to put 0, right? For case of the 4, from this 8421 how we will get 4, right? So if you choose this 4 only, you can get 4, right? So below this 4 I have to put 1 and other place I will 0. Now coming to 0. So from this you will get 0 or not? You will not get 0 from this 8421. So all the bits should be 0. You cannot choose any number. So for that all the bits should be 0, right? And from this how will get 10? 10 means A means 10, right? A means 10, right? From this 8421 format how will get 10? So for getting 10 you have to choose 8 and 2 for getting 10. 8 plus 2 is a 10, right? So for getting 10 you can choose 8 and 2. 8 plus 2, 10. So you have to, here below 1 you have to write, below 8 you have to write 1. Here it will put 0. Below 2 you have to write 1. Again you have to put 0. So you can see 8 and 2, this should be 10. Right? So now coming to this point. So from this 8421, how we will get 3? So if we choose 2 and 1, if we add 2 and 1, then you will get 3, right? So here you will put 1, here you will put 1, here will be 0. So C is equivalent to, I think, 13. A, B, C. C is equivalent to 12. Okay. So from this 8421, how will get 12? So if we add 8 and 4, you will get 12, right? So here you will put 1, here you will put 1, here you put 0, right? So in this way, you will get the hexadecimal to binary. If it is difficult for you, then how can you convert? First you have to convert hexadecimal to binary decimal number, then decimal to binary number. So again I am repeating. So each number consists of 4 digits, right? So 4 times you have to write. So for this point, this value I am writing 8421. For this also I am writing 8421. And this I have written, right? So 2. From this 8421, from how we will get 2? So if we choose only 2, you will get 2. So below 2 you will write 1 and other 0. So from this A, from this 8421 format, how will get A? A means 10. So if we add 8 and 2, you will get 10. Right? So below 8 you have to write 1 and below 2 you have to write 1. And other bit should be 0. In this way you have to write any number to the binary number in 8421 format. Right? Next is the binary to octal. Next is the binary to octal or vice versa. Okay, same procedure, but it will be different. Binary to octal or vice versa. Okay, so 1 0 1 1 1. Right? Suppose again in this number is there. This is a binary number is there. You have to convert it into the octal. For case octal number, each octal number consists of 3 digits. For case of the octal means 8. 8 means 2 to the power 3. Right? So each octal number consists of 3 digits. Right? So in case of the real number you have to combine 3 digits, okay, in like this way. So here you can see 2 digits are there, so you can put 1 0 here, okay. So for case of the fraction number you have to combine like this way, this 3 digit 1 bit, and again this 3 digit. Here no number is there, you can put 1 0, okay. Now again this number you have to write like this way. For case 3 digit number, so 3 digit number related to 4 to 1 format, not 8 4 to 1 format, right? So here I am writing 4 to 1, here also I am writing 4 to 9. Each 3 digit number can be represented as a 4 to 1 format. Here also I am writing 4 to 1, 4 to 1, right? Now I am adding. So for case of this thing, if you remember the previous one, I just add weightage of ones, right? So 0 1 0 only, I am adding only 1 this, right? This is 2. I am just adding weightage of ones from this number 2, okay. Any number is not there, any one is not there. I am just adding weightage of ones for this number. All the weightage are presented, right? 1 1 1. So 4 2 1, right? This is 7. Here weightage of 1 means only 2 is there, right? So 0.2. Here weightage of 1 means only 4 is there, right? 4 is there, now numbers are there. So 4. So number is 2 7.4 to 10. So 8. Okay, right? So I am just adding weightage of ones. Okay, here only 1 2 is the weightage. Here I am writing 2. Here all the numbers are related to weightage. So 4 to 1, right? Here 2 is the weightage only 2. So here 4 is the weightage 4. Okay. So opposite thing, by octal to binary, octal to binary, right? Suppose 460, okay. 460 is the octal number, 460.1, okay. This is the octal number. So again I told that each octal number consists of 3 digits, okay. So for 4 I am writing only 4 to 1, for 6 again I am writing 4 to 1, for 0 I am also writing 4 to 1, because each digit consists of, each octal number consists of 3 digits. For 1 also I am writing 4 to 1. So from 4 to 1, how we will get 4? Okay. So if you only choose 4, you will get 4 from the 4 to 1. So below this 4, you have to put 1 and other bit should be 0. So from 4 to 1, how we will get 6? So if you choose 4 and 2, if we add both, then you will get 6, right? So here you have to put 1, here you will put 1 and then 0. So from this format, how we will get 0? So if you you will not get 0 from this format. So all the below all the weightage you have to put 0. From this 4 to 1, how will you get 1? So if you choose only 1, you will get 1, right? So this is 1, these are 0. Okay, right? So this is the octal to binary equivalent number. Okay, so this is related to all conversions. So next class I will discuss about the binary addition, binary subtraction, and binary division and binary multiplication. So if you know this thing, you can do that thing also. This is related to decimal addition only, but little bit different. Thank you.